Here we go. So I gotta work on this thing behind me here. Not this one. This is for a little later. But this oscilloscope I just got recently. And the screen is, well, it uses a CRT. And the vertical video is a little squished. It's only taking up about half the vertical height. And if I adjust it to be as big as possible, it kind of stays in the top 2/3, and it never gets all the way to the full size. And when I was adjusting it, it also was glitching really badly. So there was another problem. I've already started. This is the video control board, and most of these caps, the brown cylinders mostly, need to be checked, and I've done a lot of that. The one that I've already replaced is, well, this is resistor here. It's an adjustment pot. The adjustment pot is had a lead broken, and that's why it seemed to actually glitch out, I think. Once I replaced that part, then the video was a lot smoother. And of course there's stream problems already. That's always fun. Alright, well, let's work on that first before we work on this. Hang on. I don't need 60 frames per second. So let's see what I can change. Stream is running. Output. Fine. I do not need 10 megabits per second video. Why would it do that? Very odd. Yeah, 60 frames per second. So it looks like I'm going to have to shut down the video for a minute to make this work better. So, hang on just a moment. Well, if I can figure out how to do that. So that seems to be working, although, oops. Let's do some settings. And video, I still can't do that. Okay, so video output is currently active. I need to turn off the output, which means I need to stop streaming altogether. Well, will this be any better? I hope so. I probably need to turn the mic down a bit again. Well, it should be started again. I'm just waiting for the stream to actually show back up again to see that it's actually working before I carry on. It's always fun to have a mess like that as you're setting up a stream the first time. Let me reload over here. Yeah, there it goes. Alright. Well, anyways, this wasn't going to be an instruction video. This was just really some peaceful recapping. So let me get you set up over here where we can see what's going on. Oh no, my cable's not long enough, of course. I really planned this out well, huh? So, let's see. Lots of fun stuff over there, but we need to see what's going on down here. Which you can't see. Well, that's a bummer. Let's see here. What am I going to do? Set this up a little higher so you can watch the cable stretch right through the middle of the view. That's always fun. That's not going to work out, is it? Okay. Let's do a little different something. Does that do anything? So you can see kind of the table and a little bit of what I'm doing. There, now. That is not the most flattering view, but who cares, right? I guess you can see all the important bits. That's all that matters. So I had a chance while I was waiting for everything to quiet down around here. Had a chance to replace most of these. First I marked all of the existing ones with a red stripe. And then as I pull them out and test them, I'm putting a blue stripe on them to mark them good, or just replacing them, which I found one bad one and replaced that. And one pot I replaced because a lead was broken on it and it was pretty glitchy. So we'll carry on. Why aren't you in bed yet, you eat?
I want to talk to you.
But you gotta go to bed.
No, I want to talk to you.
I know. You can't. You're supposed to be asleep already.
Cousin,
Yes, you eat.
I kind of want to sleep with you, but I said, Gigi, come back to bed right now, but he didn't listen.
You need to listen to them, okay? You go lay down for a while and see how it works out. Gigi doesn't want to go to bed yet.
Yes, you.
Yeah. I'm trying to work on this thing, but you need to go lay down, okay? Night night. Lost track of what I'm doing already. Right here. Stream going okay? Seems to be. Yep. see, this one is supposed to be 1 microfarad. Let's check it out in the tester. I can actually see what are we looking at here. There we go. Well, it does say 1 microfarad, so that's good. Okay, let me clean this hole up a little bit. So the pad is damaged a little bit. So I'm going to clean off a little bit of the trace and try to solder this down to it to make sure it's okay. I mean, should be, but just for extra insurance. And the other one's fine. That's going to be okay. Kids, they're adorable. Well, that one's good. Ooh, I need to fix that. Mark it. Hopefully that one bad one was all it was. Yep. So short. This one is an original 470 mic. About 410. ESR is fine. The loss is a little high, but seems okay. I have another 470 25 volt. I have a 220 470. I only have 16 volt, so we're just going to make do with that, and I'll put a mark on it. I think that is all the electrolytics. Only one was bad. I've tested about half of the ceramics. I've got one high voltage one left on here, two of these chiclet ones, and looks like two or three ceramics, and if I really want to, I will do these Teflon ones? I forget exactly what kind those are. Those are some pretty good quality ones though, so I'm not too concerned about those. And they don't blow up. So I could just leave that and be fine. But let's do this one. It is a high voltage one, so it's under a little extra stress. This is a 2000 volt, 1.5 nanofarad, 1500 picofarad, 1500 picofarad. I mean, I can't tell if the voltage, I'm not really testing for the leakage voltage on these things, so I don't know if that's accurate or not, but at least there, it's where it's supposed to be. Where did I pull this out of? Right here. Now this oscilloscope is kind of a, I think it was designed as a budget oscilloscope, where most of their HP's tools came with GPIB interface and then lots of other standard features by default. This one requires an add-on module to add it, and the assemblies inside aren't documented as replaceable, like serviceable pieces. Most HP equipment is marked, has really good documentation, schematics, theory of operation, troubleshooting guides. But this one is not. This one is set. You just replace whole assemblies. Like the whole CRT module would be replaced as one piece. So there's no schematics for this that I found yet. It doesn't mean they don't exist. It just means I haven't found any yet. Alright. But I don't need schematics to test and replace. Caps. Still trying to stay up. Quit giving him a hard time, Yui. It's time to go to sleep. So this one, as you can see, I'm doing in my lap because there is almost no risk of static damage, right? I don't need to deal with ESD safe. This thing operates at a couple thousand volts. A little static isn't going to hurt it too much, and there's nothing extremely sensitive on here anyways. It's almost entirely passive, so there's this one chip here, but I'm guessing it's hardened pretty well against straight voltages. But if I needed to pay attention to it, you are sitting on top of the ESD mat, and I've got I've got a static strap there too. Let's see, what does this say? 102, 1 nanofarad, 1000 picofarad. Yep, that's good. I don't think I'm going to take off those Teflon ones. At least not yet. I'm going to see if it needs it. We'll do some, plug this all back in and turn it on and see what happens. And if it's not good enough yet, then we'll do it. It's hot, 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 hot. Well, there are 3 ceramics left that I haven't tested. and I am not going to yet. Yeah, why not? We got it here. There's no rush. Let's just do it. Did I test that one? Let's look at the other side. Huh. Nope. Thought I did. Okay, 4 ceramics. And I should do one of those just to test it, just to see if there's, since they're all original, if one's bad, yeah, I don't know. Let's see, 1, 2, that one right there. We got to continuously clean out these little nuggets of solder, because that's what I'm sucking up out of here. This old leaded solder cleans up very nicely. Pull it out. This is a 151, 150 picofarads. Yep, 162. You don't really expect those to go bad unless you can see damage on the outside, because the outside is way more fragile than the insides. These ceramic, yeah, capacitors, the little brown buttons, they're 2 plates of metal, one's attached to each leg, and they're kind of a circle. They're just sandwiched on top of each other with a spacer in between, and then dipped in ceramic coating. So the ceramic coating is kind of fragile. It's easy to break, but the metal plates inside aren't too bad. So anything that would damage the metal plates, like an arc or something from a high voltage that it's not rated for, would almost certainly damage the ceramic coating. So if you can't see any damage, it seems like it's unlikely to have caused or to failed in any way. That's just a rule of thumb, though. It's always worth checking, which is what we're doing. And now I need 4 hands. Luckily, I have enough fingers. See, this scope was made in the 80s. Yep, 89-ish, looks like. Okay. Well, let's test this out. See what happens. Yeah. high production quality, high production value right there. All right. I think that'll do it. Yeah, let's turn it on and see what it looks like. Cute little thing, isn't it? Okay, there we go. Well, at least it still works. Ooh, that does look a whole lot nicer. It was just that one cap. And maybe the pot too, but now it needs a little bit of adjustment. Alright, let's do the screen calibration. That's still looking pretty good actually. So what we're supposed to do with this is set the, ooh, that's a little tight now. Set this brightness knob to about half bright. There's no mark on there, so I'm just gonna have to guess. About there. And then we're supposed to make the left one just visible, which it is. And then the right one we adjust the contrast of, which looks fine. Turn it to a readable level. Not quite enough. Get that brightness up a little higher. Well, I guess not too bad. You can tell the difference even at full bright. Yeah, I'm okay with that. Now we get our alignment square. I look centered left and right. Now let's do, yeah, that finally works. That's good. Let's see if the linearity works better now too. Yeah, squish. That's about right. Looks a little tilted, but I can't adjust that out. I mean, I can, just not with those. I have to turn the actual deflector, and I don't want to do that. But that looks pretty good. The interesting thing, though, is that this has a red, green, and blue magnet. Why is it colored, but the screen is monochrome? Don't know. On the next one, everything's legible. Let's adjust the focus. Squeak, squeak. That doesn't seem to be doing a whole lot, which is strange. Although, it's pretty good, so I guess I don't have to worry about it too much. Let's run the other tests. And ROM, the deck. Oh, let's measure that. Hang on. Where is my DC cal? I think that's it. Yeah, nope, it's on the back. Okay. I need a cable. Oh, don't have the right one up there. This thing is pleasantly quiet. It's always nice to have a quiet piece of tested equipment. Okay, got that hooked up. And can you even read that? No. Well, it's reading about 5/100th of a millivolt. That's pretty close to zero. Close enough for me. Oh, measure for 5 volts. 5.0002. Yeah, I'm going to say that's good. All right. Well, let's run the probe calibration. Don't drop anything in the high voltage section. Let's hit the cal. Do I need to do that again? Let's test all the buttons one more time. Oop. Yep. Stop, stop. All right, well, I guess that's it. we're done. I just got to put it back together. Thanks for coming tonight. Have a good evening.